Hi students, now we are going to solve the third numerical problem. The magnetic flux passing through a coil perpendicular to its plane is a function of time and it is given by phi b is equal to 2t cube plus 4t square plus 8t plus 8. If the resistance of the coil is 5 ohm, determine the induced current through the coil at a time t equal to 3 seconds. See, this type of numerical problem is extremely important for our board exam as well as the competitive exams. So, try to understand this type of numerical. I will write magnetic flux, okay? The magnetic flux phi b is equal to 2t cube plus 4t square plus 8t plus 8. So since the magnetic flux is a function of time, if we differentiate this equation, we get d phi by dt. So that must be equal to the magnitude, okay, magnitude of the EMF. So this is equal to magnitude of the EMF. So this is equal to d phi b by dt. So this is now equal to what? Therefore, E is equal to d by dt of 2t cube plus 4t square plus 8t plus 8. So d by dt of 2t cube is what? 3 into 2, 6t square. So this is 6t square plus 4 into 2, 8t plus coefficient of t is 8 plus d by dt of 8 is 0. So this is the expression for the induced EMF. So now we have to find the current at an instant 3 seconds. So we have to substitute t is equal to 3 seconds in this term. So this is now equal to 6 into t square, okay. So 6 into 3 square plus 8 into 3 plus 8. So this is now equal to 6 into 3 square is 9 plus 8 into 3 is 24 plus 8. So this is 9 6 are 54 plus 24 plus 8 is 32. So this is now, therefore induced EMF is now 54 plus 32 is what? 86 volt. This is the value of the induced EMF. Now if the resistance of the coil is 5 ohm means how to determine the induced current? Hence the induced current can be found from Ohm's law. So the induced current is given by I is equal to EMF divided by resistance R. So this is equal to 86 divided by this resistance is 5 ohm. So I is equal to, if you divide this means it is 17.2 ampere. Okay. So this is the required answer. At a time t equal to 3 seconds, the current induced in the coil is found to be 17.2 ampere. Okay. I hope you must have understood well. Fine.